Assalamualaikum warahmatullahi wabarakatuh. Implementation of ofPTRifanFinancindo'sSalesMarketing strategy of the customer. The basis of storage theory. AVL3 is a binary search tree which has a fixed balance between the left and right subtrays of no more than 1 for each vertex and has the same height at a difference of more than 1, and each subtree of the AVL3 is an AVL3 where each node has a balancing factor that is left height her. Left subtree right equal height left subtree right height her left subtree right. Similar to the binary tree search tree in the AVL3. There are 3 ways to operate, namely 1. Addition, 2. Search, and 3. Delete. The add operation on AVL3 is basically the same as binary search tree. In certain cases, the addition of nodes often makes the difference in height of the left and right subtrees more than 1. When adding a new node to the AVL3, there are 2 main steps, namely 1. We will trace the tree structure to find the correct nodes for addition as in the binary search tree. 2. We will trace the nodes to be added and check the the balance of nodes in the tree is fixed. If the balance does not exist, it will be rebalanced. The search process on AVL is basically the same as the search operation on the binary search tree. In the search process on AVL, it is basically the same as the search operation on the binary search tree. This is because the AVL3 is also a binary search tree by adding several properties called tree balancing. For the implementation of data storage structures in tree theory, there are 2 biggest things that can be implemented, namely static and dynamic storage. 1. Static data storage. Static storage is data storage where the memory used for storage has been prepared in advance. This data storage emphasizes the data structure by using a continuous table. 2. Data storage is dynamically implemented with the linked list concept, where the list has a reference to the first element which is used as a reference for an empty list or context. But the implementation of the list still has shortcomings for operation, searching, adding, and deleting data that must be tracked per element starting from the first element. Case study: implementation of ofPTRifanFinancindo'sSalesMarketing strategy to customer. In this case, we are using the AVL3 program. The program will display data on subscribed customer, total turnover received each month, bonuses received if sales successfully sell customer product information on the profit from each sale to the customer. This system prioritizes network development with only 2 legs or more, prioritizing network balance. The more balanced the network and business turnover of this MLM company, the greater the bonus received.
Characteristic and variable. FL3 operation insertion. Inserting a node in the FL is the same as insert node in binary search tree, where the new node is positioned as a leaf. After inserting a new node, it must be replaced on the path of newly inserted node or the innermost path. But usually, the innermost path is the path of the node that was just inserted. FL3 operation deletion node. Deletion operation is the same as in the binary search tree. The deleted node is replaced by the largest node on the left subtree or the smallest node on the right subtree. If what is being deleted is a leaf, then just delete it. However, if the deleted node has children, then the child replace it. However, after the deletion operation is performed, double check whether the tree is balanced or not. If not balanced, then it must be rebalanced. The way to balance it is the same as insertion. Rotation mode. If grouped, there are 2 rotation methods, namely single rotation and double rotation. For its use, it can be adjusted according to the conditions below. The first step is if nodes with excess subtree or left are always in the same direction. Step 2. If a node with the excess subtree or left between existing links, double rotation can be used. The first step, use the node S as the axis to pull R to the left. Then, node T will be used as the next axis to pull R to the right. Data types and implementation. Search operation for relative FL3 elements equals the search operation for the element on binary search tree. This is of course because FL3 itself is a binary search tree which is slightly modified by adding a special property, namely tree balance. Because this FL3 is also a binary search tree, then add elements to weaken also to this FL3 with the same method as binary search tree. In most cases, adding the elements, if it often doesn't make it high of increase it, so that can make the difference in height from the left and right is more than 1. However, it is not maybe this can happen. The only case where this problem arises is when the node newly added to the tree more the height of the other trees, so its height will increase and make the difference in his height to be more than 1. And this is the implementation of FL3. Thank you.
This is the program and the output of the program. Thank you for your attention. Assalamualaikum warahmatullahi wabarakatuh.